Here we go. So we're going to take the idea of set builder notation. Now, I didn't talk about interval notation. Interval notation is going to be the easier way. We're going to talk about domain and range of a function. And if and when I do, interval notation, crap, there it is used when we have an infinite number on one side. So if I was talking about a set of numbers, let's just talk about a set of numbers. Let's even dumb it down even more. If, like we had in the exercise previous, I said x is greater than equal to 3, we could write that in set builder notation, right? Yes, sir. Right? And so we would write this bad boy as all x is such that x is less than and equal to 3, and it's an element of reals, right? Because we're talking about everything less than 3, right? So that's where we were. But if I wanted to write that in interval notation, I would write it as brace negative infinity, comma, and it ends at 3, bracket. Okay, so that's interval notation. This is what we have to learn. So this is the new thing. New. We've gotten to that page yet, right? Yes.
What did you call the one on the top set?
Set builder.
Set builder.
And you already wrote that one down. We did, right?
Yeah.
Maybe I was going crazy. It's entirely possible. Now, if we were talking about x is just less than 3, the set builder notation would then be x such that x is less than 3 and an element of all the reals, right? Same thing, just different inequality symbol, but we're not including 3 in this, right? So the interval notation would be really similar. Here's the only difference. Bracket has the equal sign. Brace, no equal sign. Okay? Okay? Just like, remember, what we say, less than. No equal sign. Equal sign. Closed and open circles, remember that? That was a long time ago. Right? What were you, 7th grade? 8th grade?
Something like that, although we went over it last year.
You did go over it last year, I know you did. Good? You remember that nonsense, right?
Yeah.
Good? So why is interval notation important? Well, because This gets to be a lot when we're talking about domain and range. Now, if you can show me that you can talk about the domain and range of a function this way, right away, gone forever. We'll go right to this and leave it like this. When we take our first test, we'll use interval notation. Isn't it easier?
Wait, sir.
Yeah.
Why isn't it just like a normal parenthesis? And we said the normal parenthesis, it's like there's a little bit of symbol.
I think it's indication of a set of numbers, right? I'm going to say I don't know for sure, but we've been dealing with sets of numbers.
Also, normal parentheses are used for coordinate points.
And we don't want to confuse the idea of a coordinate pair with a set of values. That's my logical reasoning, right? We'll try and get rid of any ambiguity. Big word for you guys. I think you can handle it. You're honors kids. You understand. Good? All right. Now that we've gone through this, and this is simple, let's take a look at this page. And it talks about analyzing function graphs. And what is it we need to know about a graph of a function? Well, the first thing we need to know is its domain and its range. What would the domain of a function be?
X values.
All of the x values that are included in that function, right? And so because we've been dealing with the parabola for so long, let's go ahead and start with that because we know everything we need to know about a parabola, right? Does that make sense? Sort of.
Yeah.
Right? So if I just, everybody has this down, I can erase? I just have a simple parabola. And I'll just have it reflect sorry about that. It's not perfect. All right, here's our parabola. What would the domain be of this parabola?
The 2 points on the x-axis.
No, those are the roots.
We get an infinity to a positive infinity.
Yeah. Does that make sense?
Yeah.
You know why?
There's a sign.
It means I can put in any number and get something out, right?
Yeah.
Even if this looks like to me, f of x is x squared minus, let's say 2, right? Bottoms out at 2.
Yeah, but the range is the minimum value.
Oh, whoa, you're way ahead of me, dude. Awesome. No, this is great. Did you hear what he said?
Range is one.
Sorry about the screaming. You can get a lot of weirdness on these videos. So he said the range is where it bottoms out and everything above it. Right? Yes.
Because it's -2, isn't it shifted over to this way? Or
No.
is it shifted upwards?
Down.
Oh,
Down. Constant, up or down. Middle term starts to shift it. Okay, the x term starts to shift it. Good. Good. You guys have calculators? Here's your first task on a calculator. Who doesn't have a calculator?
Videos, John.
Come here.
Yeah, it works. Oh, you do have to. You do, okay. Is it a TI? Excellent. Ooh, color. Color?
Oh, just white.
No, I mean,
color screen. Oh,
yeah,
it is color.
awesome. That'll be great later.
Yeah.
All right, everybody hit Y equals.
TI. I think it's TI and Android. Come on. Hello.
Upper left. Y equals.
Holy shit.
That's a lot.
Hey, are you on Desmos?
Oh, yeah.
Are you lying to me?
No, I'm on this.
Come on, go get a calculator. You need to use a calculator.
It's a lot. Plot 1, plot 2, plot 3. It's a lot.
Oh my God, go get a calculator. What are the function keys on top? Y equals. Here, you want this one? Grab the yellow one if you can. No, not that one. The Inspire is just way out there. Garbage. First of all, it's not charged, so there's no way you can use it. Second of all, it's a cheater's tool.
Oh.
All right, Y equals. Ready?
Yeah.
If you put in, you may have to fix something else, but go ahead and hit X. That's the X tau theta N button here. Right underneath mode, you hit X. You hit X squared. That makes X squared.
Oh.
Look at that. Minus, right? And then 2, right? X squared minus 2. And then if you hit graph, you should see a graph of it.
Error
Son of a
window
gun.
range.
Graph is one of those function keys on the top, on the far right.
Wow.
Window range.
That's insane, that's actually insane.
All right, so
So you're
when,
supposed to hit this.
here, do me a favor. Oh!
Looks like someone's.
I got it though.
All right, if you want to reset your calculator, I don't know why somebody decided to erase this. Hit Shift 7 1 2.
Shit.
Oh, that's the wrong one.
Second.
Yo, I need one of these guys.
7. All right.
It's
Second,
just a standard
7,
graphing calendar, right?
2.
TI 84.
Yo,
This is like the standard graphing calculator.
7.
Or you could buy one.
So who's laptop?
Oh, I think they are like $100 or something. They're pretty good at math.
No more for police.
How, hello?
I'll figure it out.
You hold like start and close, shift and clear.
Oh. Shift plus 7 1 2. That's what it was.
No more for police.
Plus
Oh, memory, delete.
7 1 2, and then it's all clear. Right? It'll go back to normal, where the windows are set correctly. Our domain should be negative, our windows should be set to -10 to 10 and -10 to 10. But sometimes when kids are in here, they make it all funky. So once that's done, you go ahead and hit enter. Y equals, do your X squared minus 2 again, and you hit graph. And it'll look just like this. Okay? Now we know how to graph.
Oh.
Good?
We're-
Good? You fixed it?
Yeah.
Fixed it? Everybody's good. I apologize.
Yeah, I want to cross.
So who's laptop?
Let me reset it. Your window is set funky.
Wait, how do we reset?
So if I hit window, see how the
Some
X
old
min and
tech
X max are all goofy out there?
How do you reset it?
See how it's way
Yeah,
out there to the right?
You hold second,
Um,
right? The second.
I could
this.
just go ahead and set that.
And then
Mid
seven,
-10,
Oh, a second plus.
enter.
Second plus.
Ah,
So you go like this, click plus 7 1 2. So and then it's
-10.
Look at that.
Alright.
It's different, like a same like a five.
Shift.
You get it?
Yep.
Plus 7 1 2.
Well, we did not.
Now we'll do it. You knew how to do this.
Now what's that one? pretty neat.
Now you have to grab. Good. Sorry about that. Got to get these reset. Yeah, if you need to.
Thank
Yes, just time. Okay, now we're rolling. Sorry that took too much time. I may have to edit that out. Good,
So cool.
good.
Amazing.
All right, so if I wanted to talk about the domain, everybody said it. We have an infinite domain. From negative infinity to positive infinity. Right?
Yes, sir.
So is it, do I want to set my domain do I want to use this? This looks gross to me.
Oh my god.
Valid.
That's just every real.
Valid, that's
every
everything, right?
single number.
Right?
All of that.
You could just say, oh, well, if it's all real numbers,
Such that.
there you go.
Set of all real numbers.
Such that X is a real number. Right?
That's it.
That's a better way to say it, right? But if I wanted to write it in interval, you can't include positive or negative infinity, so that it will never be bracketed. There you go. There's interval notation of the domain.
I like interval notation.
Absolutely. Easier, right? But you know how to do this first, then I'll allow it.
I know.
Cool?
Yes, sir. Ooh.
Cool? All right, let's talk about the range. Who told me about the range?
Joe. I think.
Yeah. Cho said start at -2 and go up, right? So in in set builder notation, we'd say all the y's such that y is greater than or equal to -2 and is an element of the reals. There we go. Or we could say it's -2 to infinity. When we bracket it, then we can never brace infinity because it doesn't have a definitive value. It's included. Yeah.
For interval notation, it doesn't matter the order. Like, it's the
Yeah.
first one, the highest one.
Yes, it
Low to high, right?
Yes, it matters.
So I
Low
don't
to
that's what
high.
I asked the teacher, right?
You get into the value.
I asked the teacher, right?
Minimum value.
I asked the teacher, right?
Maximum value. It's pretty obvious.
Good.
They're so cool.
So now we're set. That's easy, isn't it? Super simple.
Pretty simple.
What else do I need to know? Oh, does it have a y-intercept?
Yes.
Yeah.
Two,
Yeah.
-2.
What's always the y-intercept?
Where's the first point that touches the.
Yo, use math language. High five. Nice. Constant. What is a constant? I heard Miss Frazier defining it.
Something that stays the same.
Yeah. It doesn't change. Do you know why it doesn't change? Ain't no variable attached to it. Right?
Yes.
So it can't change. So our y-intercept is -2. Good?
Yeah.
So we know something else about it. Look at this. We're not even talking about zeros. Oh, we are talking about zeros.
What zero are we talking about?
Where it crosses the x-axis. Now, if, should turn that off.
I was thinking,
If we looked at this graph, approximately what are the zeros of this function? Approximately.
2, -2.
Yeah, I'd go 1.5.
Oh, I knew.
It's in between.
Okay.
In between, right? So it's approximately, if you gave me 2, I wouldn't cry. So y-intercept, man, I don't know how to write. Y-intercept is -2. Roots or zeros. I think the book likes to call them zeros. Are -1.5 and 1.5. All right. Algebraically, are we going to find those roots? No. For now. We could. We could find the vertex. We could factor. We could use the quadratic formula. But it's not necessary right now. Okay? Good enough?
Vertex is 0 and -2.
Yeah. Good. Good. I'm gonna let you eyeball it with these guys. You know, your x-intercepts here. Fits in the middle. Any rough approximation, I'll give you credit for. Easy enough?
Yeah.
This is not difficult stuff, right? We're good. New. And right now we're only analyzing parabolas, right? That's good. So it says use the graph of g of x, to find the domain range of the function and to approximate the y-intercept in the zeros, then find the y-intercept in zeros algebraically. Now, for the first one, should be relatively easy. Should be, I say, because you can factor that one. I'm really sorry that my behind is blowing up. I can't answer. I'm teaching right now.
Do we do it on our own or I'm gonna do it?
Let me write it up there. But I'm not going to put the graph up there. I don't think.
So who's on?
The graph is on there, right? But let me just give you the function. It should be easy to see. The function is, well, g of x is x squared minus 4x minus 12. And we should already know the zeros right now, because we can factor, right?
What's the price as well?
Good. All right. We know the y-intercept, right?
Yeah.
Oh, man alive, Sokol. -12. Right? If you look at this function, where do you think it crosses the x-axis?
-2 and +6.
-2 and +6. Looks about right. Does that make sense?
Yes, sir.
-2 times 6 give me -12. But it's the other way around.
Or
The other way around.
it's -6.
So I was good, but
When you factor it,
Yeah,
but then when you solve it to find roots,
yeah.
that's what you got, right? You're on. Okay? That's what we see on the graph. And we're right. Good. What else? What's the domain?
Negative
Domain.
infinity to infinity.
Everything.
Every
Right.
single function.
So the domain
As
is
far as I'm aware, anyway.
all real numbers, right? Set of x's so that x
Think about how function.
is an element of real numbers. Done.
It's as far as I can.
Negative infinity,
So,
positive infinity.
Wait, so, can you explain what to use, like those, like the brackets and the.
If it includes the number, there's the equal sign. Now, we can never bracket infinity.
What if I do?
Then you have made a mistake
Like
and you will get credit taken away for using it. Is infinity
Crash.
an exact value?
It's the fabric of reality.
Is infinity an exact value?
So you can use it for most things.
So if it doesn't include that value, or it's not an exact value, like infinity, you have to use the bracket. Good? When do we use the brace? We use the brace when we're talking about
Exactly.
the range, right? So our range is what?
Negative 16 to infinity.
All right, so we're talking about the y's. Y is, we say negative, you said negative 16?
Yeah.
Is
Greater
than or equal to negative 16. And it's an element of reality.
Wait, you want to know if it's a set builder?
So
I
if
wrote them in
we
interval.
can do it in set builder notation
Okay.
for the first couple, or for the first test or quiz, then we'll just move on to interval notation. Oh, rat fake. I almost blew it. There we go. Sorry about the language. Rat fake.
So how did that come
I'm
to be
so
a
old. I'm so old.
How did that come to be a phrase?
So-
I want to know.
You know, I don't know.
Rat thing.
I don't know. It's so dumb. So ridiculous.
More than one.
Some of
way
the
to
things that
more than
come
one
out of
way
my
to skin
mouth.
a cat.
That
So
way,
how
how
does
did
that
that
think?
How does that?
You rat fake.
So
Yeah,
that's-
like
that's-
seriously,
It is a good one.
Weird.
There, sir.
just weird.
So if that's.
So how about more than?
Sound good? There it is. There's everything that you need in a nutshell. Do I have to solve this algebraically? I could take my x squared minus 4x minus 12 and factor it to x minus 6 times x plus 2, right?
It's just more effort than you need to go through, though.
Well, it's just the same thing, isn't it? Isn't our being able to see it pretty simple? Can we factor this bad boy? Yeah, we can. We can. I hope you can. But we should be able to see it. And I'm not going to force you to do it all algebraically. You love foiling and factoring? Your life's dream to foil and factor for the rest of your life? Is it an important skill? You
Yes.
bet.
Is it factor?
Yeah.
Like in life or like just here?
No, here in math. Are we going to foil and factor
No, no, no,
forever
no,
in
no.
math? Yeah.
Yes.
For certain things, we will.
Yes.
So to have that in your toolkit, very important. Here, right now, we can see it. They're giving you the graphs. Let's observe. Let's analyze through observation. Let's look at number 2.
calculate just the y value of the vertex. Well, I'm doing that wrong way.
Right?
X.
Can I do it?
Can't you do it by looking?
That's impossible. Can't.
How dare you, sir?
Uh-oh.
Come on, boy.
The middle was 6.
Are you insane? How about 4 and 2, dude? Come on.
Yeah, are you
4 and 2.
Yeah,
Look.
it's positive.
What times itself gives me negative x squared? Negative x and x.
Yeah.
And I have 4 and 2, right?
Yeah.
Right? And I need a positive 4, so I come out with 2, right?
Yeah.
So,
Oh yeah, I did see it negative at the 8. That's my bad, sir. I didn't see negative at the 8. But if it was positive, it went up and it positive.
so the rotten thing is, oh, I have a negative. Oh, no, it's a negative. Kill us. So this, 2, right? This ends up being 4.
Yeah.
Cool. Want to see how it works?
Yeah.
Let's see it.
You scared?
I'm afraid.
Why do you want to see how that works?
What plus 4 gives me 0?
-4.
We already got a negative, so if I just put a 4 there, I get 0, right? Oh, that's logic, sir.
Wow.
That's messed up. I didn't even have to do any work. Poop. All that bad language.
Immortalized on YouTube forever.
Yeah, I know.
Shoot dang.
Oh, so I subtract 4, and I have negative 4 equals negative x, right? You with me, baby? Yeah, you with me, or are you just staring into my slide? Look, negative 4 equals negative x, therefore multiply both sides by -1. Positive x equals positive 4. Good. So that's doing it algebraically, but we knew it because we're smart. Good. Not going to force you to do this stuff because you can see it. You can see it on the graph. -2 and positive 4. Good. Yes. Turn it over. Let me ruin your life. Oh no. Oh no. Now, I want you to have this with you when you do your homework tonight because symmetry is important. Yes. Yes. Want to make sure I'm running this time. Shoot. Almost.
We're on the back, sir.
I got 8 minutes.
We're on the back.
Yeah.
Talk like a car salesman, sir.
Well, it's right there in front of you. If you replace y with negative y, and you produce an equivalent equation, then it's reflexive over the x-axis, right? Which means you can fold it up along the x-axis and get the same thing.
Basically, instead of only being mirrored
So
across
it's not
the
a function.
y-axis, it's mirrored across both.
Well, no.
Kind of a flip-flop.
So if we're talking about reflecting over the x-axis, we don't have a function, by the way. You can't have a function that's reflecting over the x-axis. Here's something that reflects over the x. Come on, dude. Over the x-axis. Not a function, right?
No,
Not a function, but it is It is a relation, and there is an equation for that. So if you replace your y with negative y, and you come up with the same thing, then you know that it's reflexive
Okay.
over the x. In turn, if you want to see if it's reflecting over the y-axis, you replace x with negative x and come up with the same thing. Cool?
Yeah.
Now, that's relatively simple. Now, if it's reflexive over the origin,
0, 0, and 0.
right?
Yeah.
So we have a function. If you look at this function here, we have an odd function. Not really reflexive. That's neither. I'm going to show you a secret. You want to learn a secret?
Sure.
If this lead exponent is odd, you have an odd function.
What's the odd function?
Odd function is going to be pointing in two different directions, right? This is an odd function. That's an odd function. Because what's the exponent here? It's an implied 1. Okay? If I made this y equals x cubed, it goes like this. Still starts low, ends high. We can talk about the end behaviors. Easy, right? It's odd. There's a whole mishmash of putting in if this function is odd because f of negative x is the negative version of that function. Nuts. And we'll talk about that more tomorrow. But you can tell me by looking at the exponents, the lead exponents, whether it's an odd or even function. Okay, and we'll do it that way because I'm running out of time. I have 3 minutes and I have to hand you your homework.
Are you sure you have to do this?
Is it gonna be the quiz or are you gonna do
I don't know.
So, if I choose that. Oh, yeah.
Sir,
So,
Do them all.
that's easy.